Our fascination with achieving invisibility stretches back over thousands of years. Invisibility used to be a gift of the gods and of the goddesses. It's not often we find concealment being used for heroic deeds, though. More often, those who have this power use it with murkier motives. It may not surprise you that sex was one of them. To save her blushes, Zeus hid his wife Hera in a golden cloud so that they could make love on Mount Ida.
Then in answer to her spake Zeus, the cloud-gatherer. Hera, fear thou not that any god or man shall behold the thing. With such a cloud shall I enfold thee withal, a cloud of gold. Therethrough might not even Helios discern us twain, albeit his sight is the keenest of all for beholding. Therewith the son of Cronos clasped his wife in his arms, and beneath them the divine earth made fresh-sprung grass to grow, and dewy lotus, and crocus, and hyacinth, thick and soft, that upbare them from the ground. Therein lay the twain, and were clothed about with a cloud, fair and golden, wherefrom fell drops of glistering dew.
This is the final episode of my series in which I've explored the relationship between science and the invisible. Now, after millennia of dreaming about invisibility, science might be on the threshold of letting this dream become a reality. Some of the earliest proposals for a scientific invisibility appeared in fiction, which meant that you had to take them with a pinch of salt. A short story of 1881 called The Crystal Man by the early science fiction writer Edward Page Mitchell suggested that to vanish, you just need to make your body totally transparent.
Under the action of the etiolating drugs which the professor administered in connection with powerful detergents, I became not only white, like a bleached man, but slightly translucent, like a porcelain figure. 2 months later, I was more than translucent. You have seen floating those sea radiates, the medusa or jellyfish, their outlines almost invisible to the eye. Well, I became in the air like a jellyfish in the water, almost perfectly transparent.
Whether this would work or not, science fiction writers clearly appreciated that achieving invisibility comes down to the business of tampering with the way objects interact with light. In his 1897 novel, The Invisible Man, H.G. Wells was more sophisticated than Mitchell. His Invisible Man doesn't just become transparent, but cancels out the bending of light called refraction as it passes through his body, which would otherwise distort the background. Conjuring with light is still at the heart of the most advanced invisibility technology today. It uses an idea that is half legendary magic and half science fiction, the invisibility cloak or shield, which somehow prevents light from bouncing off the hidden object. Today, it's not just storytellers and folklorists who speak of invisibility cloaks, but physicists and engineers. And they've made them too. Over the past decade, there have been scientific reports of cloaks, shields, and other devices that can make things vanish. From humble pieces of paper to fish, cats, people, even entire buildings. The first of these cloaks was announced in 2006 by a team of researchers at Duke University in North Carolina, working with Sir John Pendry, Professor of Physics at Imperial College London.
In everyday life, we used to like traveling in a straight line, and actually our brains are hardwired to assume that. And if light doesn't travel in a straight line, then we're surprised. But that can happen. What we need to do is to steer light away from the hidden object, but keep very careful track of it so that it comes out from the far side just as if nothing had happened. You can think of cloaking a bit like turning light into water. So if water meets an obstacle, for example, a rock in a stream, it doesn't bounce off the obstacle in all directions. It flows smoothly around. And if you're a little bit downstream from the rock, then the flow will be apparently uninterrupted and you won't know that a rock's there. So somehow, to make things invisible, we've got to make light flow like water.
In order to do this, you need to use substances called metamaterials. These are unique materials with programmable physical properties that can be set in such a way as to allow physicists like John Pendry to channel light around the object in question and then pass on that light as if it hadn't come into contact with an object at all. The announcement of John's invisibility cloak caused a sensation, prompting inevitable comparisons with Harry Potter's cloak. But there's a fairly major problem here. The cloak itself didn't seem to be invisible at all. Pictures of it showed a series of concentric plastic rings, making the device look a bit like a filter in a mundane ventilation duct. So what's going on here? John Pendry again.
When you design a cloak of invisibility, it's always the case that the materials only work for a certain range of wavelengths of light. If you made a cloak that hid an aircraft, say from radar waves, the cloak would certainly be perfectly visible to ordinary visible light. And so cloaks only work in a certain band of frequencies, and that's inevitable, I'm afraid.
Invisibility in this case doesn't actually mean something you can't see. It means something that couldn't be seen using radar. That might be useful, but it's not exactly what you imagine an invisibility cloak to be, is it? We wanted to make things vanish from sight. Can't we do that too? One physicist who says we can is Jensen Lee, senior lecturer here at the University of Birmingham. I'm heading to his lab to find out more.
Hi, Jensen. Hi, Phil. Welcome to Birmingham.
Thank you.
So let me show you our lab.
We're in the metamaterials lab at Birmingham, and we're surrounded by optical tables which are covered in lenses and mirrors and lasers to do all kinds of fancy things with light. The air conditioning is whirring away to keep everything stable. But in front of us here, Jensen, is an invisibility cloak. We have a screen that I look through. There's something that looks like a prism with a mirror behind it. And in that mirror is being reflected this rather lovely toy panda. So I'll just look through the screen with the cloak off and see what I can see. Okay, so I see most of the reflection of the panda, but where the prism is, there's a bit of that reflection missing. And as I understand it, Jensen, that's because at the bottom of this prism, there's a kind of a dent in the bottom. And so that dent is like a kind of curved mirror that's reflecting the light away so that I don't see that bit of the panda.
You can't see the panda because of the curved mirror here. So what we need to do is try to fix that.
Okay, so that's what the switch does.
Yes,
Can we
yes.
give that a go if we turn the switch
so
on?
now I turn it on.
Right, okay, and now I can see the whole of the panda's reflection. There's no bits missing. But what's strange about that is that I can see when I look at the prism from above, there's a little void in the bottom. The bottom isn't perfectly flat. There's a gap in there. And in that gap is a bit of metal. A little clip is sticking down, and yet I don't see that in the reflection.
Yes, this is exactly the thing we want to hide. That's the void in between the curved mirror and the flat mirror behind. You can insert a clip, for example, here, and that will become invisible when the cloak is on.
If you didn't really follow all of this, I don't blame you. It's a complicated way to induce something we might call invisibility. But all you really need to know is that Jensen's cloak uses a clever manipulation of light to hide small objects in a little void that you can't see when it's turned on. It may well find some neat technological uses, but what's abundantly clear is that this is a very long way from Harry Potter's invisibility cloak. Perhaps that's what H.G. Wells' novel was warning us about, that when science tries to make magic real, the result will always be a bit compromised, imperfect, disappointing. So should we be discussing the real and the fictional invisibility cloaks in the same breath at all? Or should we keep a clear distinction between science and technology on the one hand, and magic and fantasy on the other? Well, I've argued in this series that, as far as invisibility goes, there never has been such a distinction, and perhaps there never can be. And there's nothing unique in that. We interpret many of our technologies through a mythic lens, framing them in terms of, say, creating life, becoming immortal, journeying through time, or reading people's minds. Some early anthropologists, encountering cultures where magic was a part of everyday life, supposed that by expressing hopes and desires, these beliefs gave people something to aim for, something that perhaps one day might become possible. Today, we can turn that anthropological gaze on ourselves and see that we are doing just the same. What is invisibility really? Is it a technical trick or a psychological one? A moral challenge or a piece of magic? A legendary attribute or a trick of the light? No matter how clever our science becomes, there'll be no easy answers.